Okay, let's work on one more example here of creating ERDs. This time let's go back to a situation like with our Gold Star database where we already have some data. Right here, our Twitter data. This has been stored and it's not normalized. We need to convert this into access later on. In order to do that, we need to decide how to break this into a set of related tables. So open this data up here and take a look at what we've got. So each row represents a tweet. By the way, the tweets here are real. However, the names and other information are fake. But what's in here, because it was actually scraped from Twitter, I cleaned it up best I could. Hopefully there's nothing too offensive in it. Don't hold it against me if there is. But what we want to do is separate this into at least 3 different entities so that we can reduce the amount of redundancy. You can see names are repeated, genders repeated. Is reshared. This means, is this tweet something that this person retweeted from somewhere else? This is the number of times this particular tweet has been retweeted. Klout represents a score. This is very common if you ever get into social network analyses. This is a score that represents how important this person is online. So how many followers do they have across all different social network platforms? How often do they get retweeted, liked, things like that. Sentiment represents the tone of this particular tweet. So the more positive the number is, the more positive the tone is. Whereas the more negative the number is, you can see how these vary from -6 all the way to, what do I have, +6? -6 means it's a very negative tone of the post. So then this is the country, state, city of where the tweeter, the person that tweeted this, resides at the time they tweeted it. So let's separate this out and eliminate redundancy. How do you want to do this? Well, let's go ahead and open up LucidChart and take our best guess. So log in, or get out a piece of paper if you'd rather. Alright, and I'm going to create a new document. Alright, let's get rid of flowchart, more shapes, let's add our entity relationship shapes. Okay, so let's go back and look at our entities here that we have. We have something about the tweeter, something about the tweet, and then we also have information about location. So let's decide where everything should go based on that. So I'm going to have one here for the tweeter, one for the tweet, and one for the location. Alright, if you can, I'd recommend seeing if you can stop the video right here and see if you can figure the rest of this out on your own just for practice. I'm going to assume you have now done your best and now you need some help, so go ahead and follow along from here. Tweeter, tweet, and location. Okay, let's store some information about the person tweeting. Alright, back here we have their name and their gender. Alright, let's start with that. Let's give that a primary key. Let's call this, often in technology, we call someone who uses the technology a user, which is kind of an odd name if you think about it. How many different fields or how many different disciplines refer to their person or object of interest as a user? Information systems and drugs, right? That's about it. Anyway, I think it's time we got a new name for what we refer to the people who use technology. Let's call this fname, and we have lname. What else did we have about the tweeter? Well, we had gender, clearly applies to the person tweeting. Okay. Alright, information about the tweet. Let's give this some type of primary key. Let's call it a tweet ID. We're going to have the text of the tweet. It doesn't really have to be capitalized or whatever we want here. And then we have some other information about the tweets. I'm just going to delete that for now. And the last one is location. Let's give it a primary key. Let's give it a location ID. What else did we have about location? We have country, state, city. Those pretty obviously apply to location. Alright, I'm going to start with the smallest though. City. Whoops. City. State. Oh, come on. Looks like we need some more. Come on, where's my, oh, settings right there. And country, there we go. All right, we have some other fields though. Let's try and decide where they should go. So we have, how about is reshare? Is this a property or an attribute of the person who tweeted, of the location, or of the tweet itself? Well, obviously it's an attribute of the tweet. So we want to put it there. And we're going to call this is reshare. All right. Next, retweet count. This is the number of times a tweet has been retweeted. So that's also going to apply to the tweet, right? Retweet count. Okay. Next, Klout Score. Okay, if you remember, and if you've forgotten, here's the dictionary explaining what all these things are again. But the Klout Score is a score about the tweeter that represents how important they are online. Their number of followers, number of times they've been liked. So it's something you'll notice gets repeated every time the person object or the tweeter object is or entity is repeated. So Nicola McGrath has a Klout Score of 42. Couple of tweets here, different tweets. Both have been retweeted once. She's tweeting from Detroit. And every time she shows up, Nicola McGrath, that clout will be repeated. So that's going to go with the tweeter, because it's information about the person tweeting. Okay, clout. Oops. All right. Next, we have sentiment. This is describing the tone of the tweet, right? Positive means it's a happy tweet. Negative means it's an unhappy tweet. All right, so this obviously has to do with the tweet itself. So let's put this one right here. Sentiment. Okay, so the next question is, how are each of these entities related to each other? So let's start by drawing some lines. Here I've got a tweeter can tweet something. A single person can tweet one or many tweets. Well, obviously many, right? So the crow's feet do go on that side. A tweet can be tweeted by, this is an individual tweet. Remember what we're representing here. A single row or record here. This tweet right here can be tweeted by how many different people? Well, one and only one. So we do want this tick mark over here. So given that this is a one-to-many relationship, hopefully you've learned by now the rule that in a one-to-many relationship, we always take the primary key from the one side and make it a foreign key in the many side. So we're going to add a column here. We'll call this user ID. And this now becomes a foreign key to represent to represent who this tweet was made by. Now, I may have mentioned this before, but a lot of times people leave foreign keys out of ERDs because whenever we have a rule that always applies, for example, in a one-to-many relationship, the primary key from the one side is always taken and migrated as a foreign key in the many side. Oftentimes people will just leave that FK out of there because it's implied by the one-to-many relationship. But I think when you're first learning these things, it's easier to put it in just to remind you. Anyway, a location. What does this apply to? A tweet is made from a location, right? Now, a tweeter also lives in a location, but the location here is referring not to necessarily this person's registered home base, but rather the latitude, longitude of the mobile device when this tweet was put out. So rather than relate location to the user or to the person, I'm going to relate it to the tweet because a person can tweet from many different locations. So I'm going to say that a location can have many tweets. Can a tweet come from more than one location? No. This is correct then. One on this side, many on this side. So let's do a quick review of minimum cardinalities then. Will we record a tweet if it doesn't have a corresponding tweeter that's tweeted it? No, we will not. So that means that a tweet must be related to at least one, but at most one tweeter. Will we record a tweeter if they've never tweeted something? Yeah, hypothetically we could. So let's make this 0 to many. So that means a row or record here does not have to relate to anything in this table, but it could relate to many. Okay, location. Will we store a location even if nobody's ever tweeted there? I can certainly imagine that being possible. Yep. So 0 to many, a location can have many tweets or none at all. A particular tweet can come from... will we ever record a tweet if it doesn't come from some location? Now this is a tougher question. What if there's some... the GPS on someone's mobile device doesn't work? Or for somehow they have location privacy turned on or turned off, they're not sharing data. So in that case, you'd say, well, yeah, we might want to store a tweet without a location. There's a few different ways to implement that. In the database later on, you could say, well, let's have this default location called Earth, and if we can't tie it to anywhere else, we will have one row on here that's just basically zeros for everything, and we call that it's somewhere on Earth, and it's still tied to that location. These are business rules that you can decide on your own how you want to implement later on. So I could see this one going either way. I'm going to go ahead and put, though, that there has to be some record in the location table that each tweet is tied to, even if that record is just referring to the entire globe, and that's why this is a minimum of 1, maximum of 1. Okay, this is our database. In the next chapter, when we implement ERDs, I'll also come back to this example and show you how to implement this with this real data. Good luck.